Hello everybody, welcome to Mathethics original channel. Thank you for watching our videos. Please don't forget to like, share and subscribe. In today's video, we will do part 2 of quadratic explicit formula. So we did a part 1 on how to write the explicit formula for a quadratic function. If you want to check it out, so in that video we use some simple tables and we use them to write the explicit formula, and in all those examples that's where we had b equals 0. Okay, so but that technique I had doesn't work for all type of tables. Okay, so some quadratic b is not 0, so in that case that technique wouldn't work. So now the standard form, in order to understand the explicit formula of the quadratic function, you have to understand the standard form of the quadratic function. So the standard form of the quadratic function is f of x equal ax squared plus bx plus c. Now in this form right here, this is the standard form. Okay, the standard form of quadratic function, and in this one, a, b and c, they are numbers. Okay, so a, b and c, they are real numbers. A, b and c are real numbers and they are not 0. Okay, so this, well, in some case a, b and c are not 0, and in some case you're gonna find that, you know, either b and c are both 0, or b only is 0, a and c are not 0, or c only is 0 and a and b are not 0. Okay, so there are all these cases. So what we are doing is we're gonna use the steps. Okay, I got the 5 steps here. We're gonna use the steps to write the explicit formula for the following tables. Okay, so the first step says to find the first and second difference. Now, in other words, the first and second difference is what tells us if we have a quadratic function. Okay, so if you do if you have a first difference, then if you have a common first difference, then you have a linear function. If you have a common ratio, then you have an exponential function. Now the second difference, the second common difference, that's what tells us that we have a quadratic function. So let's use this table right here to see how that works. Now the first thing we're gonna do is to check to see if this table represents a quadratic function by finding the first and the second difference. Okay, so that's what we're doing. So to find the first difference, we're gonna say, well, what do I add to 9 to get 6? So that's -3. So that's -3 here. 9 minus 3 is 6. And what do I add to 6 to get 5? That's -1. What do I add to 5 to get 6? That's +1. And what do I add to 6 to get 9? And that is +3. Okay, so now notice the first difference is not common, so therefore we do not have a linear function. Okay, so we have to check to see if we have a second difference. So how do we do that? So we do the same thing. So what do I add to -3 to get -1? So that will be 2. And what do I add to -1 to get 1? So again, that will be 2. And what would I add to 1 to get 3? That will be 2. So now the second difference is common. So you see we got 2, 2, 2. So the 2 doesn't change. So the second difference is common. So that's how I know I got a quadratic function. So the first difference which is this group right here, it is linear, and I know it's linear because the second one is constant. Okay, so this is constant. So that's my second difference. So we can instead say this is the first difference. Okay, first difference, and that's the second difference. So now that we have this check, we got the first and the second difference. Now we need to find the value of A. So the next step is to find the value of A. So to find the value of A is whatever the first difference is, whatever the second difference is, you take half of that, which means you divide by 2. So we're gonna take whatever the second difference is. In our case, the second difference is 2. Second difference is equal to, all right? So now if we divide it by 2, so we know that 2 divided by 2 is equal 1. So A equal 2 divided by 2, which is equal 1. So our value for A is 1. Now that we have the value for A, so we're gonna need that, so we're gonna box it. So we're gonna need that value. Now let's find the value for C. All right, so find C and f of 1. Now here's the thing, C is equal f of 0, but we do not have f of 0. So now what I'm gonna do is to go backward to find 0. Okay, so the way I'm gonna do that, so if this is 2, okay, so I can say 2 so if I have 2 here, right, so that'll be -5, right? 2 -3 minus 2, okay, -3 minus 2 is -5. So then that will be -5 in here. Okay, so so that I have -5. So what can I subtract? Okay, -5 from in order to get 9, and that'll be 14. So my term 0 would be 14. Okay, so now notice 14 minus 5. Okay, 14 minus 5 is 9. 9 minus 3 is 6. 6 minus 1 is 5. 5 minus 1 is 5. 5 plus 1 is 6. 6 plus 3 is 9. So that's this first term. And then -5 minus 2 is -3. -3 plus 2 is -1. -1 plus 2 is 1. And the 1 plus 2 is 3. So that works. So my 0 term is 14. So I pretty much go backward to find the 0 term. Okay. So now once I got the 0 term, so that will be my value of C. Now remember, on the third step, we say f of 0 is equal C. So whatever my 0 term is, that'll be my C. Okay. So we know f of 0, we know C equal f of 0. And we know f of 0 is equal to 14. All right, f of 0 is right on the table. So when x is 0, f of x is 14. So f of 0 is 14. So f of 0 is 14. So if f of 0 is 14, therefore, we can say the value of C will be 14. Okay, so now I got the value for C. Now that I have C, I have A, we need to find B. All right, next step is to find B. So to find b, we also need the value of f1. Okay, so what is the value of f1? So f1 is straight on the table, so that's when when x is equal to 1. Okay, so f1 is when x is equal to 1. That's this right here. So f1 is equal to 9. So we know f of 1 is equal to 9. So we also need that piece. So that's important. So f of 1 is equal to 9. So what I'm going to do to step 4 is doing f of 1 equal a plus b plus c. Okay, so I know f of 1. F of 1 is 9. So 9 is equal to, I know a is 1 plus b, I don't know what b is, plus c, I know c is 14. All right, so c is 14. So then we can go ahead and combine like term. We can combine like term. So 1 plus 14 is 15. So we're gonna have 9 equal 15 plus b. Now if we subtract 15 on both sides, then we're gonna have b equal, if we subtract 15 on both sides, then we're gonna have 9 minus 15 is 6. So it's negative 6 actually. So we're gonna have b equal negative 6. Okay, again, let me write that step down. So we do minus 15 on both sides of the equation, minus 15 and minus 15. Right, so that's equal negative 6, and that'll be gone, and that'll be b. Okay, so which means b equal negative 6. Okay, now that you have your a, you have your b. So you got a, you got b, and you got c, and that's all you want. So now that you have all this, you can go ahead and write out your equation. So the equation is gonna be f of x. So finally, so we're gonna have f of x equal, a is 1, so we don't need that, so that's just x squared. Okay, 1x squared plus, well actually b is negative, so minus 6x, and c is 14 plus 14. Okay, so 1 is neutral, so you don't really need that one. So f of x equal x squared minus 6x plus 14. Okay, so that is the answer for that one. So now you can check if you want to. It's always good to check your answer to make sure there is no error. So if x is 0, so what I'm gonna do, I'm gonna go up here and do the check up here. So if x is 0, so then I'm gonna have, if x is 0, then I'm gonna have 0 squared. So I'm gonna have f of x equal 0 squared minus 6 times 0 plus 14. So 0 squared is 0. 6 times 0 is 0 plus 14. So all this is gone. So I will have f of x equal 14. Okay, when x is 0, and on that table, when x is 0, y is 14. Let's check another one. Let's check the value of 3. Let's check the value of 3. So if x is 3, okay, if x equal 3, so we're gonna have f of x equal 3 squared plus or minus 6 times 3 plus 14. Okay, so that's if x is 3. So 3 squared is equal 9. 6 times 3 is 18 minus 18 plus 14. All right, so 9 minus 18 is negative 9. Negative 9 plus 14, and that will be that will be 5. All right, so when x is 3, f of x is 5, so it's 5. So let's go back to the table. When x is 3, f of x is 5. So that means this equation work. Okay, so that is the formula. We're gonna do a couple more examples, and you're gonna see. So you can see in this case, A, B, and C, all three of them are not 0. Okay, so that's why we have a full standard form of the equation. Okay, so let's do another example to see if we're gonna get something different. Okay, here's another example we have. Okay, so let's first check to see if this table represents a quadratic function by applying the first step. Okay, so the first step say, check, find the first and the second difference. So if we have a first and a second difference, then we have a quadratic function. So let's go. So we're gonna ask ourselves, what do we add to 3 to get 7? To get 10. That'll be 7. Okay, so that'll be 7. So that'll be 7. 3 plus 7 is 10. What do I add to 10 to get 21? That'll be 11. What do I add to 21 to get 36? And that'll be 15, I believe. And what do I add to 36 to get 55? And that'll be 19. Okay, so 7, 11, 15, and 19. Now, so that's our first difference. We don't know yet if it is linear. So if we have a second difference in that second difference, or if our second difference is constant, then this is a quadratic function. So let's see. What do I add to 7 to get 11? So that'll be 4. What do I add to 11 to get 15? That'll be 4. What do I add to 15 to get 19? That'll be 4. So this is a quadratic function. So because I know I'm gonna need the 0 term, so let me do it now. So I'm gonna go backward in order to get that 0 term. So if 19 minus 4 is 15, 15 minus 4 is 11, 11 minus 4 is 7. So 7 minus 4 will be 3. So that's when I'm gonna have a 3 here, right? So 7 minus 4 will be 3. So that's when 3 plus 4 will be 7. So now, which means that's for this term right here. So to get that top term, all right, to get that top term, so we need to know what do we add. So what do we add 3 to in order to get 3? All right, so that have to be 0. So if you add 0 plus 3 is 3, 3 plus 7 is 10, 10 plus 11 is 21, and 21 plus 15 is 36, 36 plus 19. Okay, so again, here's how I do it. So once I got the second difference, so I go backward. I say, well, 19 minus 4 is 15. 15 minus 4 is 11. 11 minus 4 is 7. So therefore, so 7, let me put that with a black one. Therefore 7 minus 4 will be 3. All right, that's when 3 plus 4 is 7. All right, 7 minus 4 is 3. And then, so I stop right here. Now, what I do, I work with that first difference. I'm like, okay, what do I add 3 to get 3, to get that 3? And that is 0. Okay, so, or 3 minus 3, out of 3 minus 3, 3 minus 3 is 0. So that's why I know that's my 0 term. So my 0 term is 0. So which is good. Now let's go. Now we know that a common difference is 4. All right, so a common difference is 4, so which means a second difference is 4. So A, since the second difference is 4, second difference is 4. Therefore, you can say A equal 4 over 2, which is 2. So we got our A value is 2. Now, so we got A is 2, because I want to box it. So we got A equal 2. So that is our A value. We're gonna need that number. So next thing we're gonna do is to find the C value, okay, and the f of 1. So we know the C value is we know f of 0 equals C, and f of 0 would be when x is 0, then f of x is 0. Right? When x is 0, f of x is 0. So therefore f of 0 is 0. So f of 0 is 0. Equals 0, which means C equal 0, because f of 0 is equal to C. So now we have the value of A and we have the value of C. All right, in this case, A is 2, C is 0. Now, also, we know we gotta find f of 1. Okay, we gotta find f of 1 again from the table. So what I'm gonna do, I'm gonna go back to the table. I'm gonna go back to the table and see wherever x is 1. Okay, we can see when x is 1, f of x is 3. All right, so we know f of 1 is equal to 3. Okay, so we know f of 1 is equal to 3. So we also need that piece of information. Now that we know we have A, we have C, we have f of 1. So the next step is to find B. All right, we're gonna find B. So B, so we're gonna have f of 1 equal A plus B plus C. Okay, so f of 1 is 3. So we're gonna have 3 equal, and we have the value of A is 2 plus B, and the value of C is 0. Okay, so 2 plus 0 is 2. So we're gonna have 3 equal 2 plus B, and if you minus 2 on both sides, then you're gonna have B equal 1. Okay, now B equal 1. So we're gonna have B equal 1. So, and we need that information. Now we have the value of A, we have the value of B, and we have the value of C. So all we're gonna do, we're gonna go back and plug them in the original function. Okay, the standard function. So we're gonna have f of x equal ax squared, which is 2x squared, because A is 2, plus B is 1 plus 1x. So 1 is neutral again, so we're gonna have equal 2x squared plus x. Now that answer is good, but sometimes you might want to put it in factored form. Okay, so we're gonna rewrite this in factored form as f of x equal, between 2 and 1 there is nothing in common, so I'm gonna leave it there. So between x squared and x, here we got x squared, here we have 1x. Now when you factor in variable, you always factor out the one with the smallest exponent. This have an exponent of 2. Okay, so this one have an exponent of 2 and this one have an exponent of 1. So 1 is less than 2, so I'm gonna factor out the smallest one, which is x. So I'm gonna have x here. So factor of, so if I factor 1x out of x2, so all I have left is x. Okay, plus, if I factor out that x, so I got nothing left, so I just got the 1 left. And that'll be my answer. Okay, so if you want to check your answer, we can pick up a few points, maybe 2 points, to make sure that they are the right, we got the right output. So let's see, we're gonna choose 0.2 and 0.5. okay, so if x is 2, so let's see what we get. If x is equal to 2, then we have 2x squared. So we're gonna have 2 factor of 2 squared plus 2. Okay, so 2 squared is 4, so we're gonna have 2 times 4 plus 2. 2 times 4 is 8 plus 2. 8 plus 2 is 10. So when x is 2, y is 10, and that's if you go back to the table, when x is 2, f of x is 10. So that's work. So let's try 5 now. If x is 5, so we're gonna have 2 times 5 squared plus 2. So 5 squared is 25. So we're gonna have 2 times 25 plus 2. 2 times 25 is, oh, sorry. So x is 5, so that's supposed to be 5 over here. So we replace x by 5. So 2 times 25 is 50. 50 plus 5, and that'll be 55. Okay, so it's also good. So that means the function is working. Okay, so it's just the difference in this one. Notice here we have the A term, we have the B term, but we do not have the C term. Okay, so when you do not have the C term, it's because the C is 0. Okay, so the C is 0, and it's easy. If you don't have a C term, you can go ahead and factor it and put it in factor form very easy, since you don't have the C term. So you'll be able to factor it. But if you have the C term, you cannot just factorize like that. Okay, so now let's do one more example. So one last example. Again, we're gonna do the first step by checking to see if we have if this table represent a quadratic function. Okay, so by checking for the second difference, we got on the first difference and second difference. So if the second difference is constant, then you have a quadratic function. So let's check it out. So what do I add to 14 to get 9? You know, another thing I need to say, you always want to make sure the difference on the left side is 1. Okay, so this is have to be 1. So -3 plus 1 is -2, plus 1 is -1, plus 1 is 0, plus 1 is 1. So this have to be 1. Okay, the difference of the x have to be 1. So if it's not 1, there is some more work you have to do. So 14 minus 9, well, 14, what do we add to 14 to get 9? And that will be 5. Okay, so we have 5 here. So 14 actually will be minus 5. 14 minus 5 is 9, and 9 minus 3 is 6. 6 minus 1 is 5. 5 plus 1 is 6. Okay, so that's the first difference. So let's see the second difference what we got. So negative 5 minus 3 is 2. So negative 5, you add 2 to negative 5 to get negative 3, and negative 3 to get to negative 1. So again, you add another 2, and negative 1 to get to 1, you add another 2. So that means our second difference is constant. All right, so this is our second difference right here. All right, so second difference, and it is constant. And here is our first difference, and it's linear. So now that we have the second difference, we know that it is quadratic because our second difference is constant. All right, so our second difference is 2 in this case. So now we're gonna move to step 2 by finding a. Okay, so we need to find a. So we know a is equal to the second difference divided by 2. So which means the second difference is 2 divided by 2. So therefore a is equal to 1. 2 divided by 2 is 1. So a is equal to 1. So that's checked. The next thing, step 3, is to find c. So we know c is whatever the value of f of 0. So what we need to do is to go on the table. So we're gonna check on the table and look for the value of x0. When x is 0, so I like that color. So when x is 0, okay, so that's what we use to find c. When x is 0, so f of x is 5. So that's c right here. So when x is 0, f of x is 5. So we know the value of c is 5. Right? So f of 0. So since f of 0 is equal 5, and c equal f of 0, so which means that c is equal 5. Check. Next thing we need to know is to find the value of b. The value of b, what we do, so before we find the value of b, so we need to find f of 1, because we're gonna need f of 1 to find b, the value of b. Okay, so let's see f of 1. If we have f of 1 on the table, so f of 1 right here, when x is 1, y is 6. So therefore we know f of 1 is equal to 6. So we need that number as well. So f of 1 is equal to 6. Now we can go ahead and find b. All right, so b is using that formula saying f of 1 equal a plus b plus c. So we know what f of 1 is. So f of 1 is 6. We know what a is. A is 1 plus b. We don't know what b is. And c is 5. So plus c, which is plus 5. So 1 plus 5 is 6 if you combine like term. So you're going to have 6 equal b. 1 plus 5 is 6 plus 6. So I'm gonna do my b. My student could size my b a lot as well. So that's like more b. So b plus 6. Now if we subtract 6 on both sides, yeah, my b's look funny. So if we subtract 6 on both sides, so then we're gonna have minus 6 here, minus 6 here. So 6 minus 6 is 0. 6 minus 6 is 0. So therefore you're gonna have b equals 0, okay, because 6 minus 6 is 0 here. So we're gonna have the value of b equals 0. So now we have b is 0. So now we got a is 1, c is 5, b is 0. So when b is 0, that means you do not have the x term, okay? So when the value of b is 0, you do not have the x term. So all you're gonna have is the a term and the c term, okay? So we're gonna have f of x equal 1x squared, which is 1 is neutral, which is just x squared, plus 5. Since b is 0, we're not gonna have that, plus 5. So f of x equal x squared plus 5. So we're gonna circle this right here. So that is our answer. Now we can go ahead and check to make sure this to work. So in this case, let's use -3, and then we're gonna use -1. Okay, so if x equal -1, with -1 first. So then f of x, we expect f of x to be 6, right? So we're gonna have x squared, so we mean -1 squared plus 5. -1 squared is +1, so that's 1 plus 5, and that is equal 6. Alright, so that's if x is equal to -1. So let's check to see if x is equal, and if you go back to the table, when x is -1, f of x is 6. So that's check. So let's do -3 to see if we're going to get 14. So if x is -3, we should get 14. So if x equal -3. So if x equal -3, then we're going to have f of x, we should get 14 here. If we don't, then something is wrong. -3 squared plus 5. And -3 squared is 9 plus 5, and that's equal to 14. So that's also check. So which means that equation, that function work. Okay, so the formula for this table, for this quadratic table, is working. So yeah, so the key thing here is, like, when they say like quadratic, explicit formula for quadratic function, think about the standard form of the quadratic function, okay, which is f of x equal ax squared plus bx plus c. In some cases, a, b, c will all be different than 0 or greater than 0. In some other cases, you're gonna have c equals 0, so you're not gonna have the c term, and you're just gonna have the a and b. And in some cases, you're not gonna have the b term, you're gonna have the a and c. Okay, so but the key thing is to know that once if you follow this step, it can work for anything. Okay, so if you do not have the 0 term or the 1 term, you can go backward and to find out what the 0 term or the 1 term is, and that will help you find the value for c and the value for b. Okay, so this is all I have for today. So if you have any question, please let me know. You can put it in the comment box, and if you have any suggestion or any feedback, also let me know. Thank you for watching, and I will see you next time for the next video.